Hello everyone, my name is Devarshi. In this tutorial, I will show you how to build a 3 nodes Kubernetes cluster on your personal computer like MacBook Pro or Windows Desktop using the kubeadm tool. First of all, what is Kubernetes and why do I need my own cluster? Kubernetes is an open source framework for automating deployments, managing and scaling containerized applications that facilitates both declarative configuration and automation. Although there are many online simulator tools, practice labs, and websites are available to try Kubernetes, by having your own cluster makes it easy and affordable to deploy your test applications, build proof of concepts, and even you can practice the CKA and CKAD certification exam questions at any time. You don't have to create resources and build the clusters in a cloud provider like AWS and Azure. After completing this tutorial, you will also complete one of the questions of CKA or CKAD exam to install and configure basic Kubernetes cluster using the kubeadm tool. So what is kubeadm? kubeadm is lightweight native tool provided by Kubernetes to install the cluster. If you are preparing for either CKA or CKAD, you have to be familiar with kubeadm very well, since you have to build the basic cluster, upgrade the existing Kubernetes cluster version using this command line tool. So that's an overview of Kubernetes and kubeadm tool. So let's look at the basic hardware and software requirement for our tutorial. The base computer, MacBook Pro with most recent version of OS X, or Windows desktop computer with Windows 8 and later version. Virtualization software, Parallels Desktop 11 for Mac or Windows, or Oracle VirtualBox. Oracle VirtualBox is a free virtualization software that can be downloaded and installed on any operating systems like Windows, Mac, and Linux. The guest virtual machine, each virtual machine will have the most recent stable version of Ubuntu that can be downloaded from their releases website. As you can see that 20.04 is the most recent version of Ubuntu which is in stable branch. Once you download the ISO on your local computer, you can build 3 virtual machines with the following specs. In Kubernetes, there will be a master nodes and worker nodes. The master nodes will have all the control plane components like Kube API server, etcd, Kube scheduler, and Kube controller manager. The worker nodes will have a Kube proxy and kubelets. The minimum requirements for master server is 2 gigabit of RAM and 2 CPU, while the worker nodes can have 1 gigabit of RAM and 1 CPU. We will install 3 node cluster with host names and specifications as seen in the table. So before we start, I will show you how to build 3 virtual machines in Parallels running on Mac OS. You can follow the same steps once you build 3 virtual machines on your local computer, either using Parallels or VirtualBox. So first, we will provision 3 virtual machines using Ubuntu 20.04. And once we have 3 virtual machines, we will follow these steps. Click on a plus sign, click on Install Windows or another OS from DVD or image file, then click Continue. We will select the Ubuntu ISO, continue, and then uncheck the Express installation so we can customize our installation. Here we will name our master node as kubemaster1, and we will say customize the setting before installation. So then click on hardware, and by default the processors are 2, which we will keep default. Next we will change the memory to 2 gigabytes, and then we will reduce the size of the hard drive from 64 GB, which is default, to somewhere close to 15 GB, so that we will have room for remaining virtual machines. And now we have the Cube Master with 2 CPU, 2 gigabit of RAM, and about 15 GB of disk space. This will boot the machine from the ISO, and we will follow the basic installation steps. So we will continue without updating our installation for now to make it quicker installation. And we can pick most of the default configuration for network interface. We'll bypass the proxy address. We will keep the default mirror address. And we don't want to encrypt our hard drive, so we can just say done. And then as you can see, everything will be installed in one file system called slash or root. And we will continue here. And there will be a little warning, say you want to continue, we'll say yes. And here we will set up the profile. So the name will be administrator. For the server name, we will say kube master 01, and then username will be administrator again. And we will pick the password that we can remember so that we can log in once the VM is built. In SSH setup, we will install the OpenSSH so we can log into each virtual machine from our terminal using SSH username and password. So here we will skip installing all these future packages, and then we'll just say done here. So now that security updates have been downloaded and installed, we will reboot the VM. So now that virtual machine has rebooted, we will log in as the username and password we created during installation. Once we log in, we will grab the IP address so we can log in from our terminal. So as you can see that the IPv4 address for this virtual machine is 10.211.55.18. And we will say yes. and we logged in as administrator user. Since we will be performing all the steps using root, we will do sudo to root. So now let's look at our first step. So the first step is to update the system and of course reboot after update to make sure everything is correct. Once the server comes back on, we will proceed to our next step to install the kubeadm, kubectl, and kubelet on the master node. We will go to our terminal and SSH to the server again. Again, we will do sudo su. Two steps will install the GPG key and the repository from kubenetes.io website. Then we will install all the packages that are required for Kubernetes cluster installation. Now let's check that the kubeadm has been installed correctly with the version that we need, which is 1.20, the most recent version of kubeadm tool. Next step is to disable the swap. In the step 4, we will install container runtime. To run containers in pods, Kubernetes uses a container runtime. Currently, there are 3 container runtimes are supported. The first one is a Docker, the second one is CRI-O, and the third one is containerd. Each has a different socket path, as you can see in the table. Since Docker will be deprecated from Kubernetes sometimes in 2021, we will be installing the CRI-O as a runtime environment. Let's follow the steps provided here. Once the sysctl parameters are set properly, we will reload the sysctl. Now we will add the repository that will install the CRI-O. And let's update the package. Once that is complete, we will enable the CRI-O service and we will modify the CRI-O configuration file. In this file, we have to modify a few things. First, we will update the line, which is the C group manager from default to C group FS. And then we will comment out the line that is for securing the compute mode. We will disable that in our test environment. And lastly, we will update the line to allow kubeadm.io and docker.io repository enabled on our server. So let's modify the CRI-O configuration file. We will change this to C group FS. Change we have to make is SECOM profile. In production environment, you should modify this JSON file and set your profile appropriately. For now, we will disable it. And finally, we will uncomment these lines so that registries will be enabled. Once that's done, save the file and restart the CRI-O again. We also have to create a default kubelet file which is not present by default so that we don't have to specify all these configuration parameters. So let's create this file called /etc/default/kubelet. And you can copy paste these parameters. Once that's done, you can save it. And then we will restart kubelet and CRI just to make sure everything is correct. The next step will be to pull the necessary container images. Once that's done, we will execute the command to initialize and bootstrap the master node, which is kubeadm init command. So if you are preparing for CKA or CKAD, when you run this command, pay close attention to any errors or anything that pops up because you may have to modify this command appropriately. In a worst case scenario, you can always do a pre-flight check skipping by providing skip pre-flight checks, and that will install your master node and bring it up the cluster in a running state. So this is our first command to initialize the master node, and it will bootstrap the control plane components. Once that is complete, we will set the environment for kubectl command to run. Pay attention to the output of kubeadm init command because that command will also give you a little output that you have to use anytime you want to join the worker nodes. So we can write down this in a separate file so we don't lose it. Also, we will set the environment by running these three commands. Once that is complete, we will run our first command to verify the cluster. And as you can see that the control plane is running on the master node. Install the CNI or network plugin driver on the master node. Once that is complete, now we can verify our cluster for the nodes and the system parts. So let's first verify if the node is ready. And as you can see, the master node is now in a ready state. And we will also check the parts in the kube system namespace. As you can see, all the pods are in running state, the control plane is ready, so our master node is accurate. So we will verify few more things regarding the version. So we'll check the kubectl version, we'll check the kubeadm version, and we'll check the cluster one more time. So as you can see, everything is appropriately installed and configured for our newest Kubernetes version. Let's move on to the worker nodes. So before we run these commands on a worker node and we install the packages on a worker nodes, we will build two worker nodes virtual machine. Just like master node we build, we will pick the ISO that we have downloaded for worker nodes. And we will uncheck the express installation. We will customize the setting before installation. And we'll change the hardware from 2 processors to 1 processor. 1 GB is fine. And then hard drive, we will modify and reduce the size. Once that is done, we can close this window and we will set up most of the settings as default. And we will continue without updating it. We'll keep the default network configuration. No proxy needed. We'll address as a default US archive. And we will use the entire disk. No changes here. And as you can see that everything will be installed in one file system called root. And we will say continue. Just like the master node, we will call this user administrator and we will pick the username as administrator and we will create a password. So that will set up the profile for our user to log in. And we will call this server as kube worker node 1. And we will install the OpenSSH server with the username and password authentication. We'll skip all these packages install and we will let the kernel installation complete, the file system get created. Once it updates the security package, it will reboot the virtual machine. And once it comes back up, we will log in as a SSH terminal. And we can run the ifconfig command to see the IP address. Once you log into worker node, we can become a root to install the remaining packages from 1 to 4 to install the packages and configure the system. And make sure the updates are installed and let it reboot for once so that it can configure those packages. Once the updates are installed and the server gets rebooted, we will log in back using the terminal and install the necessary Kubernetes packages. Next, we will install necessary Kubernetes tools and packages. So the steps will be pretty much similar what we ran on the master node. Next, let's verify the kubeadm version, which matches with the master node. Next step, we will disable the swap. And now we will install the runtime environment, just like what we did on master node, and set up the environment. Then we will install the CRI-O repository and the packages. Once that is complete, we will enable the CRI-O service and update the configuration file, just like what we did on a master node. Next, we will disable seccomp profile, which is secure computing mode. And we will the registries. Once that is complete, create a default kubelet file, and make sure to restart CRI-O service. Next, we will pull the necessary images by running the kubeadm config images pull command. Once that is complete, let's join the worker node by running the kubeadm join command. Once you run the kubeadm join command on a first worker node, let's head back to our master node and run the kubectl get nodes command. As you can see that we have our worker node successfully joined the master node and it is in ready state. Let's build another virtual machine with the worker node 2 and follow the same steps so that our cluster will be ready to deploy the test application. We will follow the same steps to build our second worker node. Here we can change the name to Kubernetes worker node 2 and we will customize the setting before installation. Processor, we'll change it to 1 processor. We will leave default to 1 gigabytes and hard drive, we will shrink it to 15 gigabytes. Once that is complete, we will continue. For the worker node 2, we will pretty much follow the same steps we did to create a worker node 1. In the server name, we will say kube worker node 2, same username and password. And we will install the OpenSSH server. Once the security updates are downloaded and installed on worker node 2, we will reboot the virtual machine. Then we will log in as an administrator user. And as you can see that this virtual machine has IP address 10.211.55.20. So we'll head on to our terminal and log in as a root. the same steps to install the Kubernetes tools and packages 1 through 4. And let's install the updates and reboot the server. Once the server is rebooted, we will follow the next steps. Next, let's verify the kubeadm version, disable the swap, and install the runtime environment. And let's make sure the CRI-O is enabled. And we will modify the CRI-O configuration file. Change from systemd to cgroup fs. Disable the seccomp profile. And enable the registries. Once that is done, let's create the default kubelet file. And make sure in the next steps, we will pull the necessary Kubernetes images and run the kubeadm join command. Now we will run the kubeadm join command on worker node 2. Once that is complete, head on to master node and we'll run the kube control get nodes command again. And as you can see that now we have two worker nodes and both in a ready states. If you want to check more details, you can run the same command with option wide. So that's all. Congratulations, folks. We have a 3-node Kubernetes cluster running on your local computer. So the next step, we will deploy the demo pod and install the local Kubernetes dashboard. Let's head on to the fun part. So before we install our demo pod and dashboard, let's give our worker nodes a label so that we can identify them. So the first worker node will have worker 1 label, and the second node will have worker 2 label. And if you run the same command again, now we have a master node and 2 worker nodes. So next, make sure that you have a manifest folder created on both the worker nodes. If not, then you can manually create them by running mkdir or Linux command. So we have that folder already on worker node 1 and same thing on worker node 2. So next, we will create a nginx YAML using the kubecontrol command. This little command will create a nginx YAML, the parameters inside. As you can see that the manifest has been created. We will modify the manifest to create this pod on a worker node 1. So we will delete unnecessary parameters from here. And then we will add these lines. So once you modify the nginx YAML that looks like this, we will run the next command to create the pod on a worker node 1. Let's verify if the pod has been created in a default namespace. The next step, we will expose this pod, and as you can see that the welcome page of nginx is visible. So you have successfully deployed the pod, created service, which is accessible now. Now let's install the local Kubernetes dashboard, which is as simple as running this command, which will grab all the necessary resource and create the services and pods. Access the dashboard from the local workstation by running this command. Next, let's create a tunnel that we can access the port on a local browser. So once you have a tunnel up and running, let's create a service account. And then we will apply this manifest. The access token from the service account by running this command. So next, you can open this URL in a different tab. And you can keep this default option, which is token, and we will use the token we just got. Paste the token and click sign in. And you will have this nice dashboard running on your local desktop computer. So now you have Kubernetes cluster as well as Kubernetes dashboard running on your local computer. You can explore this dashboard, which has many features available. Next, we will configure kubectl with bash auto-completion option. By configuring this, you will be able to execute kubectl command very effectively and fast during the exam, or if you are dealing with kubectl frequently. Please don't forget to clap the tutorial as well as like the video. I will be posting more topics about CKA, CKAD, and Kubernetes very soon. Folks, thank you so much for watching the video and following these steps. Hope you have enjoyed both the tutorial and video. Thank you again.